Alright, so I think this is recording. We're looking at review problems for our Skill 4. Skill 4 was a look at polynomial and rational functions. And once again, I have my cords all tied up here and I can't get it undone. Alright, I'm back. Let's take a look at, I think the next 4 problems have the same directions. We're going to look at the end behavior of these rational functions. So with a rational function, to determine the end behavior, we compare the degree of the numerator against the degree of the denominator. And whenever you have a comparison of two numbers, there's always only 3 possible outcomes. So here we have the degree of the numerator is 2. I can see the largest exponent on this expression is 2. And down here in the denominator, it's also 2. When the degrees are equal, the end behavior is a horizontal asymptote. And this horizontal asymptote is the line y equals, well, we divide the leading coefficients. Negative 3 divided by a positive 1 is negative 3. So there is the end behavior for this. Now, some students have indicated that they prefer to write, well, as x is approaching negative infinity, these y values are getting closer and closer but never touching negative 3. As x is going to positive infinity, these y values are getting closer and closer to negative 3 but never touching them. So either one of these is acceptable as the end behavior for this rational function. Let's take a look at the next problem. Again, we start out the same way. To determine the end behavior, we compare the degree of the numerator against the degree of the denominator. The numerator is written here in standard form, or at least term by term, where I can see that the largest exponent on the variable x is 4. Now, the denominator is not written in standard form, but it is written term by term, so I can see the largest exponent is 2. When my rational expression is top-heavy, when the degree of the numerator is larger than the degree of the denominator, there is no horizontal asymptote. The end behavior as you get far away from the origin, in this case, will always be either positive infinity or negative infinity. So as x is, as you move to the left on the graph, what are the y values doing? As you move to the right, extremely to the right, what are the y values doing? So we can input extreme values into this function and look at the sign of the numerator and the sign of the denominator and determine the sign of the ratio. So if I plug in extreme values that are very far away from the origin, and in this case in the negative sense, in the numerator, I can ignore these lower degree terms because when I'm far away from the origin, this x to the 4th term dominates. So I am concerned about whether the coefficient is positive or negative, not really the magnitude, but this 4 is positive. And then I'm inputting negative values. This base is negative, but it's being raised to an even power. So I know in that numerator that product is positive. Now in the denominator, the 6x doesn't really have an effect on the magnitude of the denominator when you're extremely far from the origin. So I have the opposite of x squared, and if I'm plugging in values for x that are negative and then squaring it. So like I say, the numerator is positive, but in the denominator, the base was negative raised to an even power, that's positive, but then it's saying take the opposite of that. So it's a negative value. And the ratio, when you have different signs, it's going to be negative. So as x approaches negative infinity, y also approaches negative infinity. So now to determine what's happening when x approaches positive infinity, we plug in, again, extreme values, but only in a positive sense, values that are very far to the right of the origin. And in the numerator, we have a positive number, we have a positive base, raised to the fourth power. That numerator is going to be a positive number. And in the denominator, however, we're taking the opposite of some positive value that's being squared. Well, the positive squared, that's positive, but you're taking the opposite of it, so it's negative, so this ratio is also negative. So as x approaches negative infinity, or as x approaches positive infinity, the y coordinates are going down, they're approaching negative infinity. Hopefully I said that right. I know I've written it right. Alright, so there's my answer for 19. So let's continue. Again, the directions are the same. I have this rational function. I need to compare the degree of the numerator against the degree of the denominator. The largest exponent on x is 2, so the degree of the numerator is 2. And the same for the denominator. The degree is 2. When you have the same degree, you have a horizontal asymptote, and it's the ratio of the leading coefficients. So this horizontal asymptote is the line y equals, the leading coefficient of x squared in the numerator was 5, and in the denominator it was negative 1. Well, positive 5 divided by negative 1 is just negative 5. So you can write that answer, or some people prefer to say as x is approaching negative infinity, these y values are getting closer and closer to negative 5. In the other direction, as x is approaching positive infinity, these y values are again getting closer to negative 5. So either one of these answers is acceptable. If you give the horizontal asymptote, you must write it as an equation. And here you must use the correct symbols if you write your answer this way. I think there's one more. Yeah. So again, the directions are the same. Determine the end behavior. And again, we compare the degree of the numerator against the degree of the denominator. The degree of the numerator is 3. The degree of the denominator is 4. It is bottom heavy. Every time it's bottom heavy, you will have a horizontal asymptote as the end behavior. And this horizontal asymptote will be the line y equals 0, which is more commonly referred to as the x-axis. So when you're very far away from the origin, this graph is approaching the x-axis. Now, very far away from the origin, it doesn't cross it. Up close near the origin, it might. Alright, so, well, that's my answer for 21. Now, some people prefer to write as x is approaching negative infinity, these y values are getting closer and closer to 0. I just said negative infinity and I wrote positive. Sorry about that. Hopefully I didn't do that before. As x approaches positive infinity, the y's are getting closer and closer to 0. So either answer. Either you can write it as the horizontal asymptote, or you can write these symbols. But you do have to have an equation, and you do have to group the x approaching negative infinity with, well, in this case, they're both of the y's are going to 0. Alright, so I hope that helps. I think that was 4 problems. Yes. I will talk to you later.